Hello and welcome back to another Duncan Codes. My name is Duncan, and today we are continuing with our University of Helsinki MOOC, and specifically we are looking at primitive and reference variables. The objectives from this session are that you understand the terms primitive and reference variable, you know the types of primitive variables in Java, and also that they can be practically an infinite number of different reference variables. And lastly, you know the differences in behavior between primitive and reference variables when values are assigned to them or when they are used as method parameters. Variables in Java are classified into primitive and reference variables. From the programmer's perspective, a primitive's variable's information is stored as the value of that variable, whereas a reference variable holds a reference to information related to that variable. Reference variables are always practically objects in Java. Let's take a look at both of these types with the help of two examples. So here we've got our primitive type int called value, which is stored as 10, and we've got a system out here. What we've got here is a class, which is called name. We've got an encapsulated private variable. This isn't a primitive data type, a primitive variable, interestingly, but I'm sure they'll get to that, or I think we might have already done it before, I can't remember. But anyway, so they've created this object here called Luke, and then they've system out printed it. Now, this isn't an error. This is actually the identifier of the object. And do you remember when we've been using the tostring method, that's actually been replacing this with something that is easier for us, well, something that we can understand. So let's see what they say. In the first example, we create a primitive int variable, and the number 10 is stored as its value. When we pass the variable to the system.out.println method, the number 10 is printed. In the second example, we create a reference variable called Luke. A reference to an object is returned by the constructor of the name class when we call it, and this reference is stored as the value of the variable. When we print the variable, we get name at 4AA298B7 as an output. So what's causing this? The method call system.out.println prints the value of the variable. The value of a primitive variable is concrete, which basically means it's absolute, whereas the value of a reference variable is just a reference. When we attempt to print the value of a reference variable, the output contains the type of variable and the identifier created for it by Java. The string, name at 4AA298B7, tells us that the given variable is of type name and its identifier is that number. The previous example applies whenever the programmer has not altered an object's default print format. You can modify the default print by defining the tostring method within the class of the given object, where you specify what the object's print should look like. In the example below, we've defined the public string tostring method within the name class, which returns the instance variable name. Now, when we print any object that is an instance of the name class with the system.out.println command, the string returned by the tostring method is what gets printed. So this is our addition, our tostring method. And if we print out Luke this time, you can see that we are returning this .name, so it will just print out Luke. Primitive variables. Java has 8 different primitive variables. These are Boolean, which is a true value of either true or false, a byte, which is a byte containing 8 bits between the values -128 and 127, a char, which is a 16-bit value representing a single character, short, which is a 16-bit value that represents a small integer, -32,768 and 32,767, and an int value, which is a 32-bit that represents medium-sized integers between -2 to the 31 and 2 to the 31 minus 1. Long, a 64 value that represents a large number between -2 to the power of 63 and 2 to the 63 minus 1. And then we've got float, which is a floating point number that uses 32 bits, and double, a floating point number that uses 64 bits. Out of all of these, we've been mainly using the true value, Boolean, integer int, and floating point variables double. So we've got Boolean true value equals false, int integer equals 42, and then our float. These are things very familiar to us by now. Declaring a primitive variable causes the computer to reserve some memory where the value assigned to the variable can be stored. The size of the storage container reserved depends on the type of the primitive. In the example below, we create 3 variables. Each one has its own memory location to which the value that is assigned is copied. So we've got our 3 integers. We've got 10, first and second. And then we've got a system.out.print first, second, and third. Second is being updated to 5, and then we've got first, second, and third as well. So here we are saying that second is equal to the value of first, and here we're saying that third is equal to the value of second. The name of the variable tells the memory location where it's stored. The name of the variable tells the memory location where its value is stored. When you assign a value to a primitive variable with an equality sign, the value on the right-hand side is copied to the memory location indicated by the name of the variable. So the equality sign is this, just a single equals. For example, the statement int first equals 10 reserves a location called first for the variable and then copies the value 10 into it. Similarly, the statement int second equals first reserves a memory location called second for the variable being created and then copies into it the value stored in the location of variable first. The value of variables are also copied whenever they're used in method calls. What this means in practice is that the value of a variable that's passed as a parameter during a method call is not mutated in the calling method by the method called. In the example below, we declare a number variable in the main method whose value is copied as the method's call parameter. In the method being called, the value that comes through the parameter is printed. Its value is then incremented by 1. The value of the variable is then printed once more, and the program execution finally returns to the main method. The value of the number variable in the main method remains unaltered because it has nothing to do with the number variable defined as the parameter in the method that's called. So let's have a look at this. So we've got public static void int num1 equals 1, calling the number. Oh, so call is a method, obviously, which is receiving that value, system out print number in the beginning plus number equals number plus 1, number in the end, and then system out print number still. So let's have a look through this and see what's going on. So number is here as 1. Now we jump down to this line, which calls this method. We can see that the output, so here we can see we're just about to start this line. Then we get number in the beginning, which is printed as 1. Now we're saying that we're going to say number equals number plus 1, and then we're going to print it out again, and we've got 2. Now, if we head back to the main, we'll get is number still 1. There we go. Reference variables. All the variables provided by Java, other than the 8 primitive variables mentioned above, are reference type. A programmer is also free to create their own variable types by defining new classes. So that's when we've been creating objects. What we're basically doing is creating custom data types. In practice, any object instantiated from a class is a reference variable. Let's look at the example from the beginning of the chapter where we created a variable called Levi of type name. So the call has got the following parts. Whenever a new variable is declared, its type must be stated first. We declare a variable of type name below. For the program to execute successfully, there must be a name class available for the program to use. So again, just as a sort of comparison, if you think back to our person project, that data type is of type person. Then we state the name of the variable as it's declared. You can reference the value of the variable later on by its name. Below, the variable is defined as Levi. So our person is called John, Ted, Baker, whatever you want to call him. And this is also the same for scanners as well. And in fact, any objects that you create. Values can be assigned to variables. Objects are created from classes by calling the class constructor. This constructor defines the values assigned to the instance variables of the object being created. We're assuming in the example below that the class name has a constructor that takes a string as a parameter. So this is the part that uses the constructor. So we're saying new name Levi, and we're assuming that that is taking a string of name, for example. The constructor call returns a value that is a reference to the newly created object. The equality sign tells the program that the value of the right-hand expression is to be copied as the value of the variable on the left-hand side. The reference to the newly created object returned by the constructor call is copied as the value of variable Levi. So what we're saying is that this is to the right-hand side, so this data is going to be copied into this variable on the left-hand side. The most significant difference between primitive and reference variables is that primitives, usually numbers, are immutable. The internal state of reference variables, on the other hand, can typically be mutated. So immutable means something cannot be changed, and mutable or mutated means that it can be changed. This has to do with the fact that the value of a primitive variable is stored directly in the variable, whereas the value of a reference variable is a reference to the variable's data, for example, its internal state. Arithmetic operations such as condition, subtraction, and multiplication can be used with primitive variables. These operations do not change the original values of the variables. Arithmetic operations create new rules that can be stored in variables as needed, and conversely, the values of reference variables cannot be changed by these arithmetic expressions. The value of a reference variable, i.e. the reference, points to a location that contains information relating to the given variable. Let's assume that we have a person class available to us containing an instance variable age. If we've instantiated a person object from the class, we can get our hands on the age variable by following the object's reference. The value of this age variable can be changed as needed. Primitive and reference variable as method parameters. We mentioned earlier that the value of a primitive variable is directly stored in the variable, whereas the value of a reference variable holds a reference to an object. We also mentioned that assigning a value with the equality sign copies the value, or possibly of some variable, on the right-hand side and stores it as a value on the left-hand side of the variable. A similar kind of copying occurs during a method call, regardless of whether the variable is primitive or reference type. The value passed to the method as an argument is copied for the called method to use. With primitive variables, the value of the variable is conveyed to the method. With reference variables, it's a reference. Let's have a look at this in practice and assume that we have the following person class available to us. So actually we do have this, which is great. So very, very similar to what we've got. It's got a birth year added in there, and I suppose really that's about it. We'll inspect the execution of the program step by step. So let's see. So we're actually setting the birth year to 1970. So here we've got person first equals new person called first. And because we're using this constructor here, which takes a string name, and we're saying that that name is equal to the string literal first, that value is being stored in this instance variable. And then this value, 1970, is being stored in this instance variable too. So from there, we are systemout.printing first, so we get first equals 1970, and the reason we get this and not a reference type is because we've got this toString here. And you can see that we formatted it so that it prints out the name plus bracket, the year plus bracket, etc. So then we've got the uThen method, which is being called from down here, and we are passing a person object, person, and we're saying that person.setYear, or set birth year, is equal to person.getBirthYear plus 1. So we're saying that the person is going to be the same person, but we're just adding 1 to this initial birth year here. So we are fully expecting to receive 1971, as we've got here. Then we're creating a second person, and we're saying that that person is equal to the values of the first person, so first and 1971. Then we're calling uThen second on this object, which is adding 1 to the 1971, which gives us 1972. The program's execution starts off from the first line of the main method. A variable of type person is declared on its first line, and the value returned by the person class constructor is copied as its value. The constructor creates an object whose birth year is set to 1970 and whose name is set to the value received as a parameter. The constructor returns a reference. Once that line has been executed, the program's state is the following. The person object has been created in memory, and the first variable defined in the main method contains a reference to it. In the illustration below, the call stack is on the left-hand side and the memory of the program on the right. So this is our call stack. We're calling our main method first. Then we're calling the constructor first, which is pointing or referencing to this information in memory. On the third line of the main method, we print the value of the variable first. The method call system.out.println searches for the tostring method on the reference variable that has been given to it as a parameter. The person class has the tostring method, so this method is called on the object referenced by the first variable. The value of the name variable in that object is first, and the value of the birth year is 1970, so the output becomes first 1970. On the fourth row, the program calls the uThen method, to which we pass the variable first as an argument. When the uThen method is called, the value of the parameter variable is copied to be used by the uThen method. The execution of the main method remains waiting in the call stack, as the variable first is a reference type. The reference that was created earlier is copied for the method's use. At the end of the method execution, the situation is as follows. The method increments the birth year of the object it receives as a parameter by 1. So here's our call stack. So we've got main, we've got our first constructor, then we've got make younger and person, and they're both pointing to the same reference information. When the execution of the method make younger ends, we return back to the main method. The information related to the execution of the make younger disappears from the call stack. Once we've returned from the method call, we once again print the value of the variable first. The object referenced by the variable first has been mutated during the uThen call method. The birth year variable of the object has been incremented by 1, and the final value is printed as first 1971. A new person variable called second is then declared in the program. The value of the variable first is copied to the variable of the second, i.e. the value of the variable second becomes a reference to the already existing person object. The program calls the uThen method after this, which is given the second variable as a parameter. The value of the variable passed during the method call is copied as a value for the method, i.e. the method receives the reference contained in the second variable for its use. After the method's execution, the birth year of the object referenced by the method has increased by 1. Finally, the method execution ends and the program returns to the main method where the value of the variable first is printed one more time. The final result of the print is first 1972. So let's see what we've got here. Modifying an object. So we've got a public class called counter, private int value. We've got a counter constructor, which is updating the instance value, instance variable with the argument variable. And then we've got public void modify value, which is adding the modifier to the value, and then public int get value. But we don't have a tostring method. So we've got counter equals new counter 5. So we're setting the initial value of value to 5. Counter.modify value is 8. So we're adding 8 and 5. And then we are getting the counter.get value, which should be 13. 5 plus 8 is 13. There we go. So now we've got a time machine quiz. So what will be printed? So we've got public class person, private int year. This year, so on our constructor, we're setting year to 1996. We've got a public int get year, which is just returning this year. And public void set year, this dot year equals year. So we've got private person traveler. And we've created a method. Oh, so sorry, we've got another class here. Public class time machine with a private data type of person, and we're calling it traveler. Public time machine, and we're passing the person object and the person name. So this is like string name, but we're doing person and person, or int age or whatever. And we're saying that this dot traveler equals person. So we're setting our information here. This dot traveler dot set year. This dot traveler dot get year plus years, and then we've got person Lorraine equals new person, time machine TARDIS equals new time machine Lorraine, TARDIS travel in time, so we've got travel in time 6, and then Lorraine dot get year. So we're doing this traveler dot set year. So I think the answer would be 2002. So if we look back at the code, we've got this dot year is equal to 1996. And we're looking at this line here, and we're saying that this dot traveler dot get year, which will return 1996. and then we're adding years. So if we're adding 6 to 1996, it should be 2002. That's good. Variables and computer memory. In the course's material, concrete details related to variables and the computer memory are simplified. Topics related to memory are dealt with on a level of abstraction that's suitable for learning programming. As an example, the description that the statement int number 5 reserves a location for the variable number in the memory and copies the value 5 into it is sufficient with regard to the learning objectives of this course. From the perspective of the operating system, a lot more happens when the statement int number 5 is executed. A locker of size 32 bits is reserved in the memory for the value 5, and another one for the number variable. The size of the location is determined by the type of variable in question. Once this is done, the contents of the memory location storing the value 5 are copied into memory location of the numbers variable. To add to the above, the number variable is technically not a memory location or a container. The value of the variable number is an address in memory. Information attached to the variable about its type specifies how much data should be retrieved from its address. As an example, this is 32 bits for an integer. We will return to this briefly in the advanced programming course. The topic is dealt with in depth in the computer organization course. Look at that. There we go. So that's another one done. So another short one. So I will stop the video here. Hopefully that's made a bit of sense. And obviously, if it hasn't, please feel free to ask questions. And as always, good luck and happy coding.